Hello everyone, it's September 30th. Alright, let's do this. Yes, we are doing October the 1st. That is true. Wait, really? We're doing October the 1st? Yeah, we're doing October the 1st. Alright, oh my god. Check if array pairs are divisible by k. Given an array of integers of even length and integer k, we want to divide the array into exactly half and divide by two pairs such that the sum of each pair is divisible by k. Then true if you can find a way to do that, false otherwise. So in the first one, what we want is to divide this into I have 10, so we get 5 pairs such that the sum of each pair is divisible by k. Okay, so first things first, we can add them all together, right? We add them all together and then we check if it's divisible by k. If it's not divisible by k, because what it's saying, if it exists, right? Say we have a0, a1, a2 to an, right? So let's say we can do a0, a1, doesn't matter, a2, a3, all the way down to an minus 1, an. If this is, we can say, I don't know, 5 times 5p 0, right? 5p1, 5p, I don't know, 5p n divided by 2, right? So if it's all possible, well, which means if we sum a0 all the way to an, it must be multiple of 5. So that's a first check. All right, that's a first check. Now, if that is possible, right? If that is possible, next, the goal. All right, the restrictions. Oh, negative should also count, right? Hold on. Yeah, negative should also count. Oh, negative. Damn, negative is fine. It doesn't really matter. No, it does. It does matter. Hold on. Let me, we can just return true or false, right? So it doesn't matter. So what I'm gonna do is, let's say we have minus 10 and 5, right? This one shall give me true because minus 5 is divisible. Yes. And of course, if we do this, this shall give us true as well because it's a 0. Okay. All right, so now, and we have n equal 10 to the 5th. So now what we want to do is to find the pairs that can make it work. And to make it work basically means the number, if a mod k, it has to have the same remainder, right? I think that's what we want to do. So what we can do is we create a hash map with a key being the mod, right? So in this case, actually, this is bad. This is very bad. So we have mod 1, we have 1. It's going to be like 1. Mod 0, we have 2. Actually, no, it's divided by k, right? So if it's divided by k, nothing will work. Nothing will work because you just 1 each. But if here, 1 divided by 7 is 1. 2 divided by 7. 3 as in their mod is 1, 2, 3. No, because 2, right? 2 is 2. 3, actually there's no 3 because, actually no. It's a divide, right? It's a divide, or it's divisible, right? It's divisible. So, divisible by 7, right? which means I think we shall do I was wrong. It's the sum, right? It's the sum of the two remainder has to be equal to k. Okay, how do we handle a negative value? Well, I think a negative value we can just add, we just add lots of sevens to it. Oh, first of all, I actually don't know what the rule is. Let's say -2 mod 7. To give you -2. So -10 mod 5. What do we give it? That give you 0. So if we give negative, okay, -5 mod 7, right, -5. So we say the sum has to be -12 mod 7 is -5, right? So just the sum has to be either k or -k, right? The sum has to be k minus k or 0, because 5 mod 7, right, and a 5 plus -5 will work as well. And we can also do, let's say 12, right? 12 mod 7. Oh, 12 mod 7 is 5. So no, that's not what we want. Let's try. Yeah, it's just a sum because it's a negative value. So we just need the sum to be 0 or k or -k. Or better yet, is the sum mod k equal to 0, right? Because -5 mod 5, or -5 mod 5 is gonna be 0. Yeah, it's just we do that, and let's say for -2. To get to 7, that's not possible. -2 cannot get to 7. So -2 can only get to either 0 or negative. Yeah. So I can just use k, -k or 0 to check, right? So we'll have 1 with that, and I'll have 3. How was it? That's good. I have 4, I have 5, and we have 6, right? So in this case, we check 1. In fact, n is this. We might be able to. I think to save memory, we should still use a map. So why don't I say we have 1 value, right? And then we need to go for so we can say k minus 1 or 1 minus k or -1. So that's the 3 possibilities. K minus 1, k is 7, so this is 6. This is -6. Yeah, this is basically not what we are looking at. This is if it's a negative. Right. If it's a negative, then if it's negative, that should be plus, right? No, it's now it should be either k minus 1 or -k k, a k minus this remainder, or negative k minus remainder. Right? So if r is a negative value, this will be too big, but this will be right. Yeah. So it's that. So minus k minus this, right? So that will be minus 8. That's too big, so that's not in. So minus 1 is not in. This is not in, but 6 we have 1. So now to make it possible, we should need to count how many. Enjoy. How many is in this, right? Because we want to make pairs, and this can only pair with these. So this we pair with some of those, and everybody has to pair with somebody else, right? So we can pair, right, with those. We pair like 2 or 3. Oh, what if we have multiple? You know. Because this can only pair with these, right? What if we have multiple? We have multiple ones, and we have a multiple on 6. Say we have 2 on 6, 3 on. No, so each one can only pair with two scenarios, either 6 or either this, right? And yeah, so 1 can pair with 6, or 1 can pair with negative 1. A 6 can pair with 1, right? Or 6 can pair with minus 6. So everybody has 2 choices to pair. Everyone has 2 choices to pair. Everyone has 2 choices to pair. Then who do we pair? Plus, in this case, negative 1 also has. Right? Negative 1 I can pair with 6, and I can pair with 1, or I can pair with negative 6. Right? They all have multiple ways to pair. And what we want is to find if it exists a way to divide them, to pair them. Because I can see a scenario, right, where we have multiple ones, like we can do all these pairs, but then I don't have enough pair for this. Right, like if 1 would pair everything with 6. So I'm trying to see if there is a scenario where I just there might be multiple ways to make this pairing work. That's what I'm trying to get at. There might be multiple ways to make it work. And if I do this, and then we pair with some of the 6, because I have to pair with all of them, right? So 1 has to pair with all of them. So I can count how many 6 we have, how many minus 1 we have, and then decide, right? And then decide. So if the sum of these two equal to this, that's perfect. That's the pairing. But what if we have because we have to pair 1 with all of them, right? If I have more 1s than 6 and minus 1 combined, because these are the only two options to pair. So if I have more 1s than this, that means that we cannot pair. Now there's no more pair. So it has to be the number of this is equal to this and plus this. And then we don't really care, right? We do not care exactly who pairs with whom. It doesn't matter. Now here is a question. If number 1 is smaller than the sum of these two, that means 1 can be paired, right? 1 can be paired. but we don't know how many we should go with 6, how many we should go with -1, right? Because 6 can pair with -6, and a -1 can pair with -6, right? -1 can pair with -6. Of course, 6 can pair with 1. 6 can also pair with -6 as well, and -1 can pair with -6. It's all connected. Everything is connected. So in that scenario, what do we do? Well, I think what we can do is go for the largest. What if 1 is the largest? But 6 plus -1 is bigger than 1. Yeah. 6 plus -1 is bigger than 1. Then, because all of these live together, right? All of these, 1, 6, -6, yeah, 1, 6, yeah, 1, hold on, 1, 6, -1, -6. And these 4 live together, right? So the total number of 1, so total number of 1 should be smaller or equal to total number of 6 plus -1, right? This is the goal. And the total number of 6 should be smaller or equal to total number of 1 plus -6. 好的。And total number of -1. 做题吧。So smaller or equal to total number of 1 plus the total number of -6. Wait, hold on. This is the same. Oh, wait, hold a second. And total number of -6 is smaller or equal to the total number of 6 and -1. Wait a second. This and this is the same. All these two the same. And these two are the same as well. So this says total number of 6 plus total number of -1 should smaller or equal to 2 times total number of 1 plus total number of -6. These is total number of 1 plus -6 smaller or equal to 2 times of 6 plus -1. That doesn't make any sense. That does not make any sense. No, that that does not make much sense at all. No. Hold on. Let me do that one more time. So, because 1, I say the remainder is 1, compare with remainder 6 or remainder -1, right? They compare this and compare this. So what I say is, if the number of 1 is larger than these two add together, then that's impossible. Right? That's impossible. Because then we'll have some often 1. Now if the number 1 is equal to these two together, then all of them can be eliminated. Right? All of them can be eliminated. We don't need them. They can all be paired, and we don't care how they pair. So that's good. So now the thing that's bothering me is if the number of 1 is smaller than the number of 6 and -1 plus together. Now it bothers me because there is a -6 exists, right? And the -6 can take the load off. So shouldn't we say, because -6 can deal with 6 and then it can deal with -1, right? So shouldn't we say if 1 is the total smaller equal to 6 plus 1 smaller, okay? If it's smaller, then after 1 is handled, no matter how we handle, they'll have some leftover 6 plus minus 1, right? And all the leftover needs to go into minus 6. Because if it don't go into minus 6, then like if this is bigger than this, then we have some extra. If this is bigger than this, then we have some extra here. Which means what we need is to say if 1 plus minus 6 is equal to 6 plus minus 1. So the number, the frequency of number with remainder 1 and minus 6, is that equal to the number of remainders with 6 and minus 1? So if they're equal, then yes, we can pair, right? We can pair. If they're not equal, then we cannot pair. So basically, yeah, we go through this, we do the counter basically, right? We have a counter with keys being the remainder, and then we have a positive or a negative. It does not matter, okay? It does not matter. And when we find a remainder, okay, we find a remainder, then we have its opposite remainder, which is we find a positive remainder. Doesn't matter positive or negative, right? So we find a remainder. So on the other side we have, because k always larger than 0, right? So if k minus, you know what? I think we have to make a rule out of it. All right, so we find a remainder. Well, it doesn't matter if it's positive or negative. We will set a positive, okay? We'll set r to be positive, and then this will be k minus r, right? Then we have a negative r, then we have a r minus k, right? So we have this, and then we go to the counter, we see if the sum of the counts of this is equal to the sum of counts of this. If it is, we say good, then we remove all of them if they exist in the counter. Then we move on to the next one. Interesting. How do we move on to the next one? We have to create a key set, right? So we move on to the next one. If it exists in the map, then we do the same thing. Doesn't exist in map, we already handle it. We just move on. So after we go through the whole thing, if our counter become empty, that means it's true. Otherwise, it's false. All right. Oh, let's try this.
I'm missing sock.
Oh, where?
It's on my shirt.
It's in your shirt. Awesome. Well, I have an idea of how to do this, but do we have to create a new? Yeah, I think we have to create a new. It's October, baby. October the 1st. Time flies. All right, so let's quickly do this. So first things first, what we need is the map of integer and integer. This is called remainder. I'll just call it counter. Rem counter. How about that? Hash map. And then we say for int a of array rem counter dot put a mod k and rem counter dot get or default a mod k 0 plus 1. All right, so now we have the count. Then what we do is for int key Okay, R random counter dot key set. All right, and we say we have 4 of them, right? So can we redefine R? And yeah, we just say int RR, okay? Math.abs R, right? And then we can say if, okay? If rame counter dot get or default RR, we need to compare the count of RR minus K, and K minus RR plus minus RR plus minus RR, right? This is what we want, okay? So it'll be this 0, right? Plus rame counter dot get or let's get or default RR minus K, right? And then that's also default is what the hell, 0, right? If this is equal to rame counter dot get or default K minus RR 0 plus rame counter dot get or default minus RR. What's the last one? Is also 0. So if this is true, then we have good pairing. Then we will remove, right? When say if, oh my goodness, you know what? Let me redo this. Let's do this. Int rams new int 4. Okay. So we say rams equal to new let's just create a new one every single time. Yeah. And then we can just say we still do this because it'll be easier. And then we'll say RR minus K minus RR minus R, right? So this will be a little bit simpler because here I can just call it rems 0, right? And then this is a rems 1, and this is a rems 2, and the last one is, I mean, it's not really that simpler here, rems 3. What's similar is we have good pairing and remove all of them, right? So this is where it's gonna get better because I can just say for int RRR, Jesus, of rams, we say ram counter dot remove compute. Ooh, we probably have to say if ram counter dot contains key RRR, ram counter dot remove RRR, right? So we remove it, and before we go through this, we'll just say if ram counter dot contains key R. If it does not contain, I will continue, right? Otherwise, right? So we go through all this, and yeah, and at the end we shall return ram counter dot is empty. If it's empty, it means it's good. Otherwise, it's bad. Okay, let's run some test cases. We'll use this test case. I have 3 test cases. We'll try it. concurrent modification. Okay, that's not good. Can we say new array list of this? Yep, I think I can say new array list. Okay, now let's write some stuff for it. $14.97. Get the count of each remainder, right? Each remainder when value in array mod k to have good pair matching, right? We need we need one remainder. We need to have two numbers, right? To have a pair, right, whose sum is divisible by k. The sum of their remainders, right? Their remainders must be divisible. Must be either k minus k or 0. Now for a remainder, for a positive, right? Positive remainder r, its matching remainder can be minus r or k minus r, right? And for minus r, its matching remainder, hold on, for minus r and k minus r, they are their other, right? They're no, not minus r and k minus r. Minus r can have minus r. What's the other one? It's r minus k. R minus k. Yeah, for their other matching remainder is r minus k, right? Thus, for all of them to match, right? For all of them to match, we need the count of r and r minus k to equal the count of minus r and k minus r, right? Because otherwise there will be some remainder that do not have a match, right? So they just have to match, right? They just have to match. So we use this to examine if a remainder can if a remainder can find all its matches in the array. Okay, so we call it on because I didn't do anything else. There is a while loop, a for loop here, but that's only 4, so that's fine. Okay, so now the task is, let's run this and see if it works. Hopefully it does. It is not. Okay, so that's pretty bad. That is pretty bad. We passed 95 out of 97 and then we fail. Oh my goodness. Oh my goodness. Output true, expected false. Interesting. Some edge case, I guess. And that's 2. Oh, we didn't do one check. Hold on, I forgot one check. So there's another check is total, right? For int a of array, total plus equal to a, right? If total mod k is not equal to 0, return false. That's another one. I'm not sure if this one will handle, because expected false, right? I'm not sure if this one can handle it, but maybe it can. Let's take a look if I can. Yep, I forgot this. Why it cannot check? Some edge case, right? Because when we handle this, there is this so first round of naive check. A first round naive check is to see if the sum of all array can be divisible by k. If not, there is no way to arrange the pairs. Okay, so I hope this will satisfy. All right, let's try it. Oh my. Oh, 96. Dude, don't tell me there's any overflow. I don't think there will be overflow in this case. Do we have overflow? I don't think so, because the count, nothing is, I mean, these are kind of big. Okay, this one overflows. All right, this one overflows. Maybe. Okay, so let's we can do this, right? You know, I'm not 100% sure, but I just clicked into the solution. Now we don't want a solution. I don't want a solution at the moment. I am still working on it. Okay, I'm still working on it. Let's try this. Okay, this one's working. Let's try this. Oh, yeah, it's overflow. All right, something overflows. Always check for overflow. There we go. Right, always check for overflow. So the logic and everything was correct. It's just you cannot use int. Man, I haven't all the time. It's never paid attention. All right, so now what we need to do is to go to the solution and see what is the idea. Well, apparently you don't have to do this. I think this is different. I think this might be smarter. Okay, let's take a look. So we have a map. We get there. We're going and we say I minus. So this one guarantees everything is positive. Oh, everything is positive. Damn. Okay, everything is positive. Then we just need to make sure that because everything is positive, you only have one option. There's no negative, so everything is positive. So so what is trying to say is if you hit a -1, well, plus 7, so this will become a 6, right? And this will become a 1. So basically all the 1s need to equal all the 6, right? So that means we probably don't need this part. Hold on, we can try this as a solution too. I think it's worth us doing a solution too. Okay, let's do a solution 2. Okay, solution 2. Make all the remainders positive. Then we only need to check two matching remainders. Also, yeah, 2 matching remainders. Also, we probably don't need to use the naive first round check. Okay, so that is the. So let's comment on this. Okay, and we have this. So we'll say int r. It's fine. I can do it here. A mod k plus k mod k. Okay, and then we do this is gonna be r, and then this is gonna be r, and then blah blah blah. Actually, it's fine because we will match no matter what. Yeah, I think okay. Let's do this. So I'm not removing anything. Okay, so we just say if rem counter dot get or default r 0 is not equal to rem counter dot get or default k minus r 0, right? If these two are not the same, we'll return false immediately. Otherwise, we keep going and we'll return true. Dude, if this one passes, I am going to be a very, very unhappy man because it's so much simpler than my original idea. Okay, we can probably put both big test cases in, and I'll try it. Yeah, dude, I think it works. Interesting. Does it make it faster? It does. First round naive check also make it faster. Can't speed up algorithm. So I'll just put it this. Okay, so this is hopefully it'll be faster. Oh no, it's not right. Ha! I thought. Really? I thought it has to be equal. Is it not? The total number of r and the total number of k minus r. Ooh, what the hell? What the hell? All right, let's check this. I'm surprised that this is not right. System.out.println r. We have to go string.format. R equals %d. K minus r equals %d. And basically we'll print this both count r equal to %d, count k minus r equal to %d. Alright, so we're gonna do r, k minus r, this and this. I'll just take a look. we just take a look and see r equal to 0. Oh, my bad. Damn, I forgot about 0. Shoot. Okay, my bad. Yeah, I forgot about 0. Woo. So if r is equal to 0, okay, and rem counter dot get or default 0, well, they will always have 0, so I can just say get 0 mod 2, right? Mod 2 is not equal to 0. If that or rem counter dot get. Okay, so we need some more parentheses. So we need parentheses here, we need no parentheses here, and we need a parentheses here. Okay. Yeah, I forgot about the remainders 0 situation. Yeah, we need this. Are you kidding me? Oh. Ah, my bad. Yeah. No. It's the logic. It's the logic. Damn it. See, this is just extra work. Can speed up the algo. Alright, so this is just work. That's terrible. So basically, if it's 0, we have to handle it differently. If r is equal to 0, right, we have to handle it differently. Right? So we say if rem.counter.get 0 mod 2 is not equal to 0, then this one we need to return false. But otherwise, it's fine. So we have to say else if, and we'll do this giant portion. We say here, and we also return false. So if r is equal to 0, we use this. If r is not equal to 0, we have to use this, right? Yeah. Okay. Come on, this one should be right. Give me some. There you go. All right, let's check on this one as well. Yep. All right. I think this is right. Really? Wow. Okay, I did not expect this one to be wrong. 94. Huh. I don't know. I am I don't know, honestly. now I'm confused. Cause this is the same algorithm as before. Seriously, it's the same algorithm as before. We have long, we handle this we handle the R correct, right? R is correctly handled. What else did I not do right? And R equal to 0, and now we say rem.get 0. Wait, what did I not do? Yes. Objects are equals. Object are equals. What did I do wrong? Come on. Tell me, what did I do wrong? Well, I think the only difference is this goes through array, and I'm going through the R. I don't see if there's any difference in the two. Alright, is there any difference? No difference. This is the same. Right? This is the same. And instead of going through this, I am going through the R. And I say if R is equal to 0, right? And with mod 2, then we return false. Else if the get our default R, alright, there's one possibility. There's one possibility. If it's true, I'm gonna be very, very mad. I think we overflowed here. Dude, these things are just... I am not happy. I am not happy at all. So we do... Oh my god, how do I even do this? So we take long. But they didn't do it. It didn't do it. It's just int. Everything is int. That's why I don't think so. Everything is int. Like what the hell? Yeah, everything's int. It's I do not understand. Now, whatever this is, I do not understand. But I don't think, just by looking at it, I don't think that's the reason. Okay, I have no idea why this one just failed. I literally have no clue why this one failed. It's the same algorithm, right? It's the same algorithm, except it's the same algorithm. I mean, the only difference... Okay, let's see if this is the reason. It shouldn't. It shouldn't be, because we included this earlier. Yeah, it shouldn't be. It's not this. It's something here. Something here is wrong. Okay, you saying I have to use this? I don't think so, but I'm willing to entertain this idea of object dot equals rem counter dot get r, rem counter dot get k minus r. Objects. You are kidding me. You are kidding me. What in the world? What in the world? Holy crap. What? Dude, I should have copy and paste that line. Now I have to redo this. Oh my god. %d, 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 %d. R, k minus r. You better give me a good excuse for this. Otherwise, I'm gonna be very. I am already angry. Okay, at this point, it's supposed to be in half an hour problem. Now they're just getting down to 1 hour mark, and I missed my training today with my skateboard. Are you shitting me? Are you telling me 153 is not equal to 153? What? Wait. Okay, this is I don't know what happened. I think I have some idea why, but so far I'm refusing to believe that's the reason. But this directly is false. Oh, it makes sense now, because here I think this converts them into integer. Oh, this is an object. Foo and bar is, no, that converts integer, so it'll be fine. But directly it's an object. An object is not equal to, oh, wow. Okay. Ooh. Fair enough. Hey, yeah, you learn, right? This is a part of the learning experience. Okay, I do not regret spend that much time to debug this problem. Yep, I understand. Pay attention. That values from the counter from hash map, from the map, cannot compare directly without first converting to to primitive types. If you want to compare the values directly, you must use object.compare. No, that equals. Wow, this one bites me. This one bites me. I kept forgetting this. All right, here's the problem. Okay, why does the other two just simply works? Right, why does the other two simply works? Because we ran the other examples and then they work. So my question is, why does the other one work but this one does not work? That's, doesn't make any sense. Well, it does probably because the other one doesn't really have this problem. I mean, it could be many issues, could be many reasons, but yeah, I do not want to speculate on that. All I want right now is to get this problem done and over with. Man, every single day it's 1 hour. Easy question, 1 hour. Difficult question, 1 hour. This is beyond bonkers. And we have a sorting. So what do we do? Sort. You sort, holy crap. You sort based on their, okay, yeah, you put, okay, yeah, put the left and right, so you save on the memory. You also don't save on memory. Space is okay. This space, on or log n. Yeah, we have the sort, and then you go 2 pointers just to check if they, just to check if they are the same. This is convoluted for convoluted sake. Yeah, was not very happy, but yeah, anyway, we got it done. Okay, that will be it. I will see you guys tomorrow. Adios.